Alright, welcome. In this video, we're going to solve equations that have radicals in them. And I think you'll see that for the most part, this is going to play out like we expect, but with the occasional twist. Now, the first equation I've got for you to solve is a pretty basic one. What values of x make the equation 2 square root of x equals 8 true? And I think this is one we can solve with our eyes. We can look at this and say, okay, well, I need this square root of x to be 4, and I need to plug in 16 to x for square root of x to be 4 and for 2 times 4 to equal 8 and the equation to be true. So I say I'm looking for probably x equals 16. But this is actually suggesting that we can solve this kind of like any other equation, right? We could start by dividing both sides of this equation by 2 and saying, okay, well, that means that the square root of x is equal to 4. And then we'll kind of do the opposite thing is always what we're trying to do. And so the opposite of square root would be squaring both sides. And so I'd say, that squared equals this squared. And the square root of x times the square root of x, well, that's just x. And that's where I would get 4 times 4 is 16. Negative 16 wouldn't work because 2 times the square root of negative 16, well, that's 8i. Okay, we learned about that recently. Okay. Oh, I was also going to point out what we did here was we took both sides to an appropriate power that happened to be the reciprocal of a power of x that I was already dealing with, right? Whoops, that wasn't what was supposed to happen. So I had the square root of x, which is x to the 1/2 power, and I took that to the second power, the 2 over 1 power. And that'll be relevant later on when we solve equations that have like rational exponents in them. But before we get into too many of those equations that, have more going on with them, I should probably just give you the steps that we're going to take to solve these radical equations. And I'm also going to, off to the side, work an example and kind of like, highlight which step is going where. So the first step is going to always be isolate the radical. Okay, this equation, the radical is already isolated because I've got the square root of x plus 30 equaling x. And when you say isolate, we just mean like get it on one side of the equation all by itself. Step 2 is going to be take both sides of the equation to an appropriate power. In this case, that's going to be squaring both sides, right? Because I've got the square root of x plus 30, so I need to get rid of that square root by squaring. And that's going to be taking both sides to the second power. And you probably won't see me write that step in general, or maybe at all after this, but if I square the square root of x plus 30, I'm going to get x plus 30, and that's going to equal x squared. And that's the second step. The third step is going to be, solve for x kind of like we normally do. Now, in this case, we've got a quadratic equation, x plus 30 equals x squared, and I've got x squared and x. I've got two different powers of x, so I'm going to have to set this thing equal to 0 and hopefully factor. But if I can't factor, I know that I'll be able to solve this with the quadratic formula. Either way, I'll be able to solve this equation. So 0 is going to equal x squared minus x minus 30. Okay, and this is something we're going to be able to factor. We're going to say two numbers that multiply to negative 30 while adding to negative 1 would be negative 6 and positive 5. Okay, so I've got those factors, and that product would equal 0 if x was equal to 6 or if x was equal to negative 5. Alright, so I've solved for x, but that's not it. I need to check my solution if I squared both sides of the equation. And this equation right here is a perfect example of why you do need to check your equation, if you check your solutions to your equation if you squared both sides somewhere along the way. So I'm going to go over here and check, and you don't always have to write this out, you can kind of mentally check usually. But for x equals 6, I'll plug into the equation and say, all right, is the square root of 6 plus 30 equal to x? Yes. Okay, great. But for x equals 5, or no, negative 5, I'm going to plug this in, and I'm going to get the square root of negative 5 plus 30, which is 25, is equal to negative 5. And that's not true, right? Remember last time we said that the square root means the positive square root. So the positive square root of 25, that's not equal to negative 5. This is not true. And so I go and I cross out x equals negative 5. That's what we would call an extraneous solution. which is something we've actually already seen in this class. I think when we were solving equations that had absolute values in them, that we could solve down an equation, get a solution, and then go back and check, and it wasn't actually true after all. Okay, and just to really emphasize, the reason that I needed to check was that I squared both sides of this equation. And I did that right here, right? And the reason that this can happen, well, you know, something like 5 and negative 5 are not the same number, right? But if I square them, they do become the same. That's really like the mechanism at play here. And that's not the case when you take, you know, numbers like that to say the third power or the fifth power. And that's why I wouldn't need to check my solutions if I, you know, say took both sides to the third power. Okay, but this is true, you know, if I take both sides to any even power, because, you know, taking to the fourth power is like squaring twice. All right, now here are some basic examples, and I think oftentimes these are ones that we can solve with our eyes, but it's good to start with those and then work those out algebraically so we can kind of connect those steps. So why don't you try these on your own? Either think about what you think the answers are going to be to these four, or pause the recording and just kind of scratch out a solution to each of these four, and then you can check your answer against mine, because I'm just going to bring it in here in a second. All right, there you go. So the top two, I ended up squaring both sides because, you know, the x to the 1/2 power, that's the same as the square root of x. And then I made sure to check my answer. You know, I could have done this mentally. I just was reminding you visually that I did check. And then the bottom two, you know, I was going to cube both sides, okay, to get rid of the cube root or to get rid of the 1/3 power. And those I don't need to check, right, because I did not square both sides. All right, now these next two are going to be the first ones that we're going to encounter that have kind of like something like a fraction exponent that's not just an old-fashioned root. So this one, we learned last time that we could call x squared's third root x to the 2/3 power. And I am going to do that in a second, but I think first I'm going to kind of maybe show you what isn't going to be the best strategy. If we just look at this like too robotically and we're like, okay, on the very outside I've got the cube root, so I need to cube both sides. That's going to rely on us knowing, you know, the cube of 9, and that's going to be kind of hard. We can do it, right? It's 9 times 9 is 81, and 81 times 9 is going to be 729. Okay, I can see how that arithmetic works. But then we're left taking the, wait, no, not 789. Hold on. 729. Think about that for a second. Yeah, that's 729. But I don't know what the square root of that is. I have a feeling it's 27 because this number is bigger than 400, which would be the square of 20, and it ends in 9. Okay, and 7 times 7 is 49, and I don't think it would be 23 times 23. But then, you know, I'm kind of hoping for a calculator or relying on arithmetic skills that I might not have. So there's a better way to approach this, in my opinion. We're going to solve this with fraction exponents. And so remember last time I told you that the cube root is the 1/3 power. I also told you that this was going to work out to be x to the 2/3. But I'm just going to remind you of why this is true. This is power of a power. We're going to multiply the exponents. So this is going to be saying x to the 2/3 is equal to 9. Okay, well, what I'm going to do now is I'm going to take both sides to the reciprocal power. So I'm going to take both sides to the 3/2 power. And then this is something that I can do. I can deal with the denominator first to keep the numbers manageable, like I told you to last time. Okay, on the left side, I'm going to have x, and that's going to be equal to 9 to the 3/2. And so I'd take the square root of 9 and then cube it. Okay, and I would get x equals 27. Okay, and what did I have to think about what I did to both sides here, because, yeah, there's a little bit more to think about. Right, so kind of the question I hope you're thinking is, did I square both sides? Do I need to check my answer? And so we need to look and see, you know, what did we do to both sides here? We took both sides to the 3/2 power. Okay. And so what we did was we kind of like cubed it and then took the square root of both sides. And I hope, but I'm not necessarily expecting that when I said you took the square root of both sides of the equation, that might have set off some sort of alarm in your head. I was like, I'm supposed to remember something when I take the square root of both sides of an equation. And when we take the square root of both sides of an equation, we do need to bring in a plus minus. Okay, so let's go back and actually think about what's going to happen with this number here. This 27 squared cubed rooted, evidently it's equal to 9. Okay, I trust that. Okay, 27 to the 2/3 power is 9. I do know that for a fact. Okay, but what happened was first the number got squared and then it got cube rooted. Okay, and it wouldn't actually matter in this case if it went in the opposite order, but sometimes it does. Okay, if I had had negative 27 and I had squared that, it would become the same as what I would have gotten if I'd taken positive 27 and squared it. And then I took that to the 1/3 power, that's still going to equal 9. So, since I took the square root of both sides, I needed to have, x equals plus or minus 9 to the 3/2, which would end up bringing me x equals negative 27 as well. So that's something we do need to be careful about. Okay. And then the second example, I'm thinking, yeah, okay, this one, still kind of the same considerations, but I'm going to take both sides to the 2/3 power. So I have x to the 3/2, I'm going to take it to the 2/3, and that's going to be the same as 27 to the 2/3. Okay, I took both sides to the 2/3 power. Okay, and then I'm going to have x on the left, and I'll just have 27 to the 2/3. So I'm going to deal with the denominator first. I'm going to take the cube root, because it's the 2/3 power, so I take the third root. And then I'm going to square that. Okay, the cube root of 27 is 3, so this is x equals 9. Okay, I go back and I think to myself, what did I do to both sides? I took both sides to the 2/3 power, so that's squaring and then taking the cube root. Taking the cube root and then squaring. And so, since I squared both sides, I do need to check my answer. Okay, but I don't think, the thing that can go wrong with these equations is like, taking the square root, having a positive square root come back negative, plugging in a number into a square root and having it lead you to taking the square root of a negative. I'm not sure if that will happen in this class, but that is the thing that can happen. But if I think about taking this 9 here and putting it in for x, 9 to the 3/2 is equal to 27, right? If I take the square root of 9, that's 3, 3 to the third is 27. This does work. I've checked my solution. I'm ready to move on. Solve some equations that have radicals on both sides. Okay, so this one's, pretty nice. Okay, I think you'll like this one. We've got square root equals square root. Okay, I think it would stand to reason that the numbers on the inside of the square roots would need to be equal. Okay, or we could think about it as we're squaring both sides. It's kind of the same thing. So if these two things are equal, then 2x plus 5 is going to have to equal x plus 7. And I could subtract an x from both sides. And then I would get x equals 2, right? Because 2 plus 5 is 7. Okay, I did square both sides when I went from here to there, so I do need to check my answer. But I think this is one that we can check mentally. Okay, when I plug in 2 to the left side, I get the square root of 4 plus 5. Okay, this is the square root of 9. And on the right side, I've also got the square root of 9. The square root of 9 is equal to the square root of 9, so this is my solution. Unfortunately, not all of them are that easy. So, something just like a little +1 out there can really cause big problems for us. I wouldn't say problems, but it's going to be more involved to solve this equation. So, you can try to do different stuff with it, but there's not going to be anything you can do to deal with the fact that you've got a +1 on the outside of the radical. We're not going to be able to subtract it over to the other side. We've got the equivalent problem over there, right? We can't combine these. We don't have any radical properties for that. It's not just that we don't have them in Algebra 2. They don't exist. So what we're going to do instead is we're just going to square both sides and we're going to put in the work. So we're going to say, all right, square root of x plus 2 plus 1. If I square it, I have to multiply it by itself. And unfortunately, that's not just going to be x plus 2 plus 1. There's going to be a middle term. And then we're going to square the square root of 3 minus x, and that's where we'll get 3 minus x. Okay, so I squared both sides of this equation. I will need to check my solutions at the end. Okay, I'm going to set up, I'm going to do the FOIL. Okay, square root times square root equals the thing on the inside, the radicand. Okay, so I've got an x plus 2 from the first two, plus, Okay, the outside 2 and the inside 2 would be the square root of x plus 2 times 1. So if I add those together, I'll get 2 of these square roots. But I'll write it out for you. Wait, no. X plus 2 plus another square root of x plus 2. And then the last 2 would be 1 times 1. That's equal to 3 minus x. Okay, so I'm going to combine all of these, including the x plus 2 and the plus 1 over here on the left side. So I'd have an x plus 3 plus 2 square roots of x plus 2 equaling 3 minus x. Okay, and now look at this. I've got another radical equation, and so I'm going to kind of follow the same four-step process on this equation. I'm going to isolate the radical, I'm going to take both sides to the appropriate power, and I'm going to solve for x and then check my answer. Okay, so I think the first step is going to be subtracting an x and a 3 from both sides. And then I might divide both sides of that equation by 2 and get the square root of x plus 2 equals negative x. Okay, well, I've got the radical isolated. I need to take both sides to an appropriate power. If I've got the square root of x plus 2, I'm going to need to square that. Get that square root out of there, so I'll say x plus 2 is equal to the square of negative x. Now if I take the square of negative x, just reminding you what you already know, I'm going to have 2 negatives and 2 x's, and we know negative times negative is a positive, so this is equal to positive x squared. Okay. And then kind of like the other one I solved, the first example, I've got a quadratic equation. It's got an x squared and an x in it, so I'm going to need to set this thing equal to 0, factor, and solve that way. Alright, so I've set it equal to 0, but I've kind of run out of room, so I'm going to go back over here and start to factor. So what are two numbers that multiply to negative 2, add to negative 1? That would be negative 2 and positive 1. Okay, so 0 will equal x minus 2 multiplied by x plus 1. And I can say, okay, I know when this would equal 0. This would equal 0 when x was 2, or when x was equal to negative 1. Okay, and now I need to check both of these answers for their validity. And when I'm checking, I'm going back to the original equation that was printed in ink for you. Right? It's important that we go to that, not to some, equation that we've written down along the way. Okay. So I'm going to go over here and I'm going to check. Okay, so x equals negative 1, that's the one that I might expect would be the extraneous solution if I hadn't already worked this problem. When I get x equals negative 1, or when I plug that in, I'm taking the square root of 1 plus 1, that's 2, equals the square root of 3 minus negative 1. Okay, yeah, that's the square root of 4. Okay, this works, yes. Okay, when x equals positive 2, I'm going to plug that in. I'm going to have the square root of 4 plus 1, so that would be 3, equaling the square root of 3 minus 2, so that would be the square root of 1. And no, that's not right. Okay, that's not true. So I'm going to go and I'm going to get rid of x equals 2 because that was an extraneous solution, and x equals negative 1 is my only solution there. But I would say that, at least in my class, this is about as bad as it would get. Alright, now if you're following along in my notes book, then you've probably noticed that there's a lot of examples coming up, but I'm not going to work all of them in this video. I'm going to probably record my solutions to all of those examples in a separate video and just call it more radical equation solving examples, something like that. Okay, you could even find a link to that video, put right there, if I remember to do that. But I think these 4 would be good for you to practice on, just to make sure you've kind of got everything at a basic level. Do these 4 on your own, pause the video, work them, and check your answer against mine. And if you can do all 4 of these, then you've got probably a good baseline understanding and would be ready to go on to the homework, and might not need to do all of those examples, that are in the following pages. Alright, so pause now. The answer is going to show up in like 5 seconds. Right, there you go. So all 4 of those solved pretty easily. I might suggest a little bit more practice, but the homework's got all sorts of examples on it of mixed difficulty. Okay, so if you found all 4 of these easy, you're ready to go on. Okay, if you didn't find these four easy, you should go back and review the examples that we did together, but you should look at the other examples too. And one thing I was going to point out was that, this x equals negative 21, I'm glad this was on there, because although x was a negative number, that didn't necessarily mean it was an extraneous solution, right? If we plug it in, we got that the square root of 4 was equal to 2, and we're happy with that. So I think that's going to be all for this video. Thanks for watching.